So welcome to today's lesson. We're going to discuss why normal saline is considered an isotonic solution. Now you may have taken this for granted to assume that normal saline is isotonic, but when you look at it on the surface, it doesn't seem to make sense, and here's why. The concentration of sodium in normal saline, as you know, is about 154 milliequivalents per liter. And yet the concentration of sodium in a patient is approximately anywhere between 135 and 145 milliequivalents per liter. So how is it that a solution like normal saline can be considered isotonic when the concentration of sodium in it is about 10 to 20 milliequivalents greater than the concentration of sodium in a patient? How is it that this statement is true, that this solution is isotonic? So that's what we're going to discuss. And to understand how this is actually an isotonic solution, we have to understand compartments. So let's talk about sodium in a patient. Where is sodium residing specifically? Well, we know the overwhelming majority of sodium is in the extracellular space. Now, we have many compartments in the extracellular space. We know that most of the sodium is in the intravascular space. And this would be extravascular. It turns out that the intravascular space has compartments itself, and the largest compartment is what we call serum. Serum is made up of a variety of components. The two largest components are red blood cells and plasma. Plasma, it turns out, is made up of components as well. Plasma is made up of two components, something called plasma water, which we're going to discuss further, and the lipids and the proteins that are in circulation. So that's it. This is generally the breakdown of what's going on in the extracellular space. Now, when we measure sodium in a patient, we're measuring serum sodium concentration here. In some laboratories, and probably in more laboratories, we're measuring plasma sodium concentration. So we're going to focus on plasma sodium concentration. A lot of doctors and students may interchange the words serum and plasma, but as you can see from this diagram, serum is not the same as plasma because serum contains red blood cells. So we'll be accurate and we'll be referring to the sodium concentration that we're accustomed to seeing as plasma concentration. And that's the 135 to 145 milliequivalents per liter. Okay, so we've established the sodium concentration that we're measuring. We're measuring plasma sodium concentration. But it turns out that all of this sodium is not evenly distributed between plasma water and lipids and proteins. Even though we're measuring the plasma concentration of sodium, almost all of this sodium, all of the milliequivalents of this sodium are found here in plasma water. So how much sodium is actually found here? What's the concentration of sodium in plasma water? Well, to figure that out, we need to know how plasma is divided into these two components. It turns out that 93% of plasma is plasma water, and therefore 7% is about lipids and proteins. So if we want to know how much sodium is in plasma water, which I'm going to indicate as this, if we want to know this entity, we do a simple mathematical calculation. We say 0.93 times this entity that we want to know, which is the concentration of sodium in plasma water, is going to equal the concentration of sodium in plasma. We're going to pick a number that we most commonly see, 142 milliequivalents per liter. I just chose a number that was relatively in the middle of this range. So when we solve for this entity, this is what we get. It's approximately 154 milliequivalents per liter. Now this number is familiar to all of us because that's how much concentration of sodium we see in normal saline. So normal saline is actually an isotonic solution because normal saline is pure plasma water, so to speak. That's all that's in a normal saline bag. And if you want to achieve a sodium concentration in your plasma, which is what you generally measure in the laboratory, of 135 to 145 milliequivalents per liter, you're going to be administering a solution that's generally plasma water that has to have a concentration of sodium of 154. Because normal saline doesn't have any lipids or proteins, you need a higher concentration of sodium in order to get this range of sodium. And that's why normal saline, despite on the surface not appearing to be isotonic, is truly an isotonic solution. And that ends today's lesson. Thank you very much.